Here's a fun problem from an international science competition for middle schoolers called Naboj Junior. Take a circle and draw 13 distinct points along its perimeter. Your job is to determine in how many ways can you draw two line segments that start and end in these points such that they don't cross and don't share an endpoint. That is, in how many ways can you join two pairs of distinct points without the lines overlapping? How would you approach this problem? Give it a shot and comment your answer and your approach below. Here's one way we could tackle this. Let's first look at a small problem. If we select 4 distinct points, in how many ways can we join them with two lines such that the lines do not overlap? Turns out the answer is 2. There is this way and this way. The third possibility is this one, but here the lines overlap. So whenever we have 4 distinct points, there are 2 ways in which we can join them according to the rules. Knowing this, the question simplifies to, in how many ways can we pick 4 distinct points from the 13 points we were given? Well, if we start picking one by one, we have 13 options for the first point, 12 for the second, 11 for the third, and 10 for the fourth. That gives us 13 times 12 times 11 times 10, which is 17,160 options. Is that it? Well, not quite. We did some overcounting. In our calculation, we didn't care about the order in which we picked the points, and that's why we overcounted each quadruple of points. The same 4 points were counted as unique quadruple whether they were picked in this, or this order. Thus, to adjust for our mistake, we should divide the 17,160 options by the number of distinct orderings of each quadruple. That's given 4 distinct points. In how many ways can we order them? Well, we again have 4 options for the first point, 3 for the second, 2 for the third, and just 1 for the last. That gives us 24 unique orderings. So to adjust for overcounting, we need to divide our 17,160 options by 24, since we overcounted each option 24 times. That leaves us with 715 unique quadruples of points. Nice. All that's left to do is to combine the 2 pieces of information we just uncovered. Given that there are 715 ways in which we can uniquely pick 4 points out of 13, and that whenever we have 4 points, there are 2 ways in which we can join them according to the rules, there must exist 715 times 2, which is 1,430 valid ways of drawing 2 line segments that do not cross or share a point in our picture. And that's it. That's the answer. If you enjoyed this problem, you can find many more creative problems like this one linked in the description below. And if you are a 13 to 14-year-old math geek or a math teacher from one of these countries, check out Naboj Junior and register to compete against other math geeks in Europe. This year's competition will take place on the 24th of November. Thanks for watching, and don't forget to like, share and subscribe for more visually pleasing math content. See you in the next one.